All right, guys, I only have a few more weeks of review with you, so I'm going to jump into chemical reactions. So if you remember, in your notes, we talked about different types of chemical reactions, and there are 5 main types with a couple subtypes in there. So I'm just going to go over each type and how you can predict the products for each type. So the first type is synthesis. Okay, and a synthesis reaction is easy to spot because it's always going to have 2 simple substances as your reactants, usually single elements. So a single element and another single element. The reason why there's a 2 there is because nitrogen is diatomic. Okay, so you have 2 single elements typically in a synthesis reaction, and a synthesis reaction always just has one product. Okay, just one product. And so if you just have 2 single elements, what you're going to do is you're going to put them together. So this is a metal, this is a non-metal, so we need to create an ionic compound. So that means we need to crisscross the charges. So I'd look up my periodic table, and I'd see that magnesium is a +2, nitrogen is a -3. I'd crisscross those charges and make it into one compound. So it'd be Mg3N2. Okay, and then you could go back and balance that. We won't worry about balancing right this very second. Okay, so that's how you do a synthesis reaction. You always just make one product. Now, what's the opposite of a synthesis reaction? The opposite of a synthesis reaction is a decomposition reaction. Decomposition reactions. And it's very, very easy to spot a decomposition reaction because decomposition reactions always just have one reactant. Okay, so we just have one reactant here. And in this case, it's a binary ionic. Now, there are 3 different scenarios you can get when you are doing decomposition reactions. And these are the 3 different scenarios that could show up on your test. Okay, and it is that you could have a binary ionic, which is like this one. So we're going to break it up just into its elements. So I've got cobalt and I've got bromine. So I'm going to make cobalt and bromine. And bromine's diatomic, so I can't let it be all by its lonesome. I got to put a 2 there. Okay, and you could go back and balance that. So very simple. The other situations you might be given, and these are in your notes, are if it's a metallic carbonate, it would break up into the metal oxide and carbon dioxide. If it's a metallic hydroxide, it would break up into the metal oxide and water. Okay, so you might see those as well, so keep those in mind if you see that for a decomposition reaction. Okay, and again, you know it's a decomposition reaction because there's only one reactant. Okay, one reactant. Okay. Synthesis is one product, decomposition is one reactant. Now, the next type of reaction I want to go over is combustion. Okay, combustion. So combustion should be super easy, like the easiest type of reaction to spot and to predict its products. Because a combustion reaction is always some sort of hydrocarbon, so something with carbon and hydrogen in it, combining with oxygen, O2. Okay? And every single time you have a hydrocarbon reacting with oxygen like this, in a combustion reaction, you're going to make carbon dioxide and water. It doesn't even take much thought. That's it. Okay? And then you go back and balance that. So that's a combustion reaction. All right. Now, let's move on to single replacement. This out of the way. Single replacement. So in a single replacement reaction, you have a single element and a compound. Okay? Now the single element is always going to switch places with the thing that's most like it in the compound. So in this case I have zinc. Zinc is a metal, so it's going to switch places with the metal. Okay? So these guys are going to do a swap. The zinc and the copper. So now instead of zinc being by itself, the copper is going to be by itself. And the zinc is going to pair up with the chlorine. And when we make, a new ionic compound, we always have to crisscross our charges properly, right? So zinc has a +2 charge, so we got to crisscross that. And then you go back and balance that. Okay? If this was a non-metal, it would switch places with the non-metal. Now, if you have a situation where this is like 2 non-metals, like a hydrogen and a chlorine, then because hydrogen's positively charged, like a metal, it would switch places with that. So if this was zinc and this was like hydrogen instead of copper, the zinc would switch places with the hydrogen because the positively charged things are similar, so they would swap places. Okay? So that's a single replacement reaction. Now, the last type of reaction is a double replacement reaction. But within double replacement reactions, there are two types, okay? If you remember, there are two types that we learned about this year. There's precipitation and neutralization. So let's write double replacement. And then within that, there's going to be the subtype. And we're going to do, let's do precipitation first. Okay, so precipitation is a type of double replacement reaction. Here's an example. Now, you know it's a double replacement reaction because you're going to have two compounds. Okay, unlike any of these others, this is double replacement reactions are the only ones where you're going to have two compounds. So you're going to look at those two compounds, and if it's not an acid and it's not a base, then it's going to be a precipitation reaction. Okay, so like this one's here. So what we have to do is we have to have two things swap places. Instead of this, just one element swapping, it's going to be, because there's two compounds, two things are going to swap. So the silver and the rubidium, because this is a metal and this is a metal, those things are going to swap places. So now the rubidium is going to go with the nitrate. And rubidium has a +1 charge, so it's just going to be RbNO3, and nitrate has a -1 charge. And then the silver is going to go with the bromine. And silver and bromine both have a charge of 1 as well. Okay? And then you could go back and balance that if you need to, although I think it's already balanced. Now, in a precipitation reaction, the most important thing is to figure out what your precipitate is. Okay? So there are some solubility rules that I gave you guys. And these are solubility rules. These things are soluble. Anything with an alkali metal, anything with nitrate, anything with ammonium. So if I look here, this has nitrate in it. So that means this is going to be soluble, which is going to be aqueous. Okay. This does not have any of these three things in it. Because it doesn't have any of these three things in it, it is considered insoluble, or a solid, or a precipitate. So that one would be your precipitate. Precipitate. Okay, so something, a test question I could give you is, I could give you something just like this, and I could say, hey, what precipitate is formed in this reaction? And you'd have to be able to put it together and recognize that because of these solubility rules, this is going to be your precipitate. It's going to be insoluble, meaning it's not going to dissolve in water. Okay, so that's precipitation reactions. Now the last type I'm going to go over is neutralization. Okay, so neutralization. Neutralization are also sometimes called acid-base reactions. The way you can spot these is, first of all, you know it's a double replacement reaction because there's two compounds. And you know within double replacement, it's neutralization because it has an acid and a base. This one's going to be your acid. This is going to be your base. How do you know? How do you know that's an acid and how do you know that's a base? This is an acid because it starts with hydrogen. If it starts with hydrogen, it's an acid. You know this is a base because it ends in hydroxide. If it ends in hydroxide, it's a base. So if you have two compounds, one of them starts with hydrogen, one of them ends in hydroxide, you've got yourself a neutralization reaction. And a neutralization reaction always makes water and a salt. So water and a salt. And when I say salt, I mean an ionic compound. So the ionic compound that's left over, when you use up your hydroxide and your hydrogen to make your water, you're left with sodium and nitrate as your salt. And those both have a 1 charge. So it's just going to look like that. Okay? So that is how you do that. Okay? You make water and a salt with neutralization reactions. So it's very important that when you come across a chemical equation, you first look at what type of reaction is this. Okay? And once you figure out the type of the reaction, it's easier to figure out what the products will be. Okay? And if you look at your notes, I believe it's page around 37-ish. It looks like this. You can use your notes, okay? You can use your notes. So use them. Don't just guess. Don't just blindly guess. Figure out what type of reaction it is. And then from there, you can predict the products, okay? All right, go ahead and do the assignment. And as always, you can message me if you have questions.